Okay, so you would have copied this. Make sure you have all of that in your composition book. Now I'm going to fold it up because I'm going to keep it in mind too, just in case somebody asks me. So I can say I have it in mind also. All right. So we were going to do proof by contradiction. This is the last proof we have to do for this week. Proof by contradiction. A proof by contradiction is when you assume the opposite and show that it leads to an absurdity. So I'm going to give you an example in math. So how about I'm going to leave some space for the definition. I'm going to give you the definition here in a second. But I want to give you the example first. So suppose I have something like 4 equals 2x. All right, so 4 equals 2x. Proof by contradiction. So suppose I want to prove that x does not equal 3. Prove that x does not equal 3. So on a proof by contradiction, you would actually do the opposite. Think of it like this. Suppose you say I can lift a car over my head. That doesn't make any sense, does it? You can't lift a car over your head. But you could use a proof by contradiction to do that. You could say, well, try to lift it. Because what you're proving is that you're trying to prove that this person cannot lift a car over their head. I want to prove that you cannot lift a car over your head. So what you do is you start with the opposite. You say, okay, let's assume you can lift a car. Let's see what happens there. Person says, okay, well, they can't lift the car. That's the contradiction. But let me show you this math example. So 4 equals 2x. I want to prove that x does not equal 3. And I'm going to use proof by contradiction. So I'm going to assume the opposite. Always start with that. So assume the opposite. So assume x equals 3. And for the definition, I'm going to put that also up here. So assume the negation. Assume the negation. And once we assume the negation, what we're trying to do is show something that doesn't make sense. All right? We're trying to reach an absurdity. And I'm going to show you what that means down here. So assume that x equals 3. Then, by substitution, always give a reason. By substitution, that was on that long list of stuff that you copied. Substitution rule was on there. Property of substitution for equality. So assume x equals 3. Then by substitution, 4 equals 2 times 3. All right, so 4 equals 2 times 3. Is that right or wrong? Hopefully you guys know that that doesn't make sense, that it's wrong. And that's what we're trying to go for here. We're trying to get to something that doesn't make sense. So assume the negation for our definition. So assume the negation. And then show how it leads to a contradiction. And I'm going to put in parentheses something crazy. Because when we talk about contradictions, that's what we're talking about. We're talking about something crazy. So assume the negation, then show how it leads to a contradiction or something crazy. All right, so again, our example, 4 equals 2x, prove it does not equal 3. So we assume that it equals 3. We do the opposite. All right, we do the opposite. And then we just follow through with it. We go along with it. It's like somebody's telling you a lie and you just kind of go along with it. You're like, yeah, okay, sure. Wow, yeah, you were in a movie? Oh, yeah, we should watch that movie. I bet you're in the credits. Just go along with it. So I'm going along with it here. Okay, x equals 3. But I end up over here, 4 equals 2 times 3. That's not right. That doesn't make any sense. Because 2 times 3 equals 6 by multiplication. And so you'd say this is a contradiction. A contradiction. So x does not equal 3. Because we tried to show that it did equal 3, but we got to a contradiction. So if x cannot equal 3, I'm sorry, if we find out that x cannot equal, if I say x equals 3, but I end up with something crazy, we say it like that. If I say x equals 3 and I have something crazy as a result, that means it cannot be 3. So x does not equal 3, just which is what we were trying to prove right over there. All right. Now, on the homework, it'll say something about proof by contradiction for division by 0. Now, if you remember, anything divided by 0 is undefined. If I say 6 over 0, well, that's just undefined. And I want to see what you guys come up with on that one. I want you to show me how it's actually undefined. Undefined means that you can't find a number to satisfy it. Because I'm going to give you a little hint. If I say A over B equals C, if I say something like that, well, that's also the same thing. That implies, actually, I can do if and only if by the rules of algebra and arithmetic, actually. I could do if and only if. So A over B equals C. If and only if. Okay, so I could multiply both sides by B and cancel out. So I'd have A equals B times C, which makes sense. Because always test numbers out if you're not sure. Like 6 divided by 3 equals 2. So let's see. A is going to be 6, B is going to be 3, C is going to be 2. So does this make sense over here? Does 6 equal, see, B, my B is going to be 3, C is going to be 2. Does 6 equals 3 times 2? Yeah, that makes sense. So now try it out with, switch it up. What about A divided by 0 equals C? All right, so try to think of a way you could do a proof by contradiction. And again, with proofs, you can never write too much. All right. Okay, I'll let you get to it. Have a good weekend, guys.